Hello, today I want to talk about pulley problems. So let's say we have this type of thing where on the surface there is a big M and a small m, that's how we're just going to call them right now. And they're connected to via pulley with a configuration as shown. Well, this type of thing, or this type of pulley system. So we need to find the conditions when the blocks just begin to move. So like this one goes down and this one's go to the right. So let's break it down. How, what? However, in this part, we know, like we get told in the question, there's no actual question like altogether. So we get information of step by step. So there is friction between the big M and this one. So it's somewhere over here. And the friction is trying to like stop the M, like it's pulling it towards itself. So the big M is getting pulled by friction. This situation, in these type of situations and questions, we should draw the free body diagram of each block so we can see what forces are applied to them. Now let's talk about the small m. So as if like the body diagram would look kind of like this. So we have the m, right? The gravity pulling down is mg, and then the rope has a tension. It only pulls, it can't push, so the arrow would go towards up because it only pulls. And now let's do the big M. So the big M has the same tension that this one has. So it has the same rope, so the tensions are the same, which is good. It has the frictional force, which goes this way because it's friction. It has the gravitational force, and it has the normal force. And since they both have the same rope, they will accelerate with the same value. Like it's like while this one will go down, like how quick it will go down. However quick this goes down, this will go right the same speed as this one. So the accelerations will be the same value, and because of that, them being the same, we're able to use the equation of motion. So you know the Newton's law where F equals ma. Over here we have mg, we have the t, so we're able to write mg minus t equals acceleration. Because if the acceleration is the same, we're able just to find kind of the acceleration or whatsoever. So for the big block, the normal force and the gravity force cancel each other out, because if it's not moving, then it will be moving. However, right now it's not, so they cancel each other out. So n equals mg. However, the friction is equal to the micro of n. So micro is 10 to the power -6, and that times the normal force is equal to the friction. Now we're able to say the maximum of static friction is equal to F micro mg. Yeah, so we're also able to apply the Newton's second law. Tension minus friction equals to the ma. And since the F is equal to micro mg, we're able just to write it micro mg instead of the t. F, I mean. The t's cancel, like, now we add these two, so the t's cancel out. Now we're left with the mg of the small, so just small mg, because it's a small one, equals ma, and then micro times the big mg equals ma. And don't forget that these two are equal, so mg equals big mg, and both equal ma. I forgot to add the micro squared. Now if we divide everything by m, like the two m's, the small one and the big one, because this one represents the small kind of one. Because so basically in this one there's two m's in general, because there was a big one and a small one. So there's these. If you divide each of them by the m and the big M, we are left with mg minus micro big mg divided by m plus big M equals to acceleration. But since we don't really care about the value of the acceleration, we just care when will it start moving, we're able, and it to start moving, the acceleration should be bigger than 0, so this should be bigger than 0, so we're able to say that mg, take away micro mg, should be equals more than 0, and the g's cancel out, so we're left with m, it's bigger than micro m